Hello dear student, how are you? I am here again to represent another online classes for chapter 2 of electrostatic potential and capacitance. In the previous lecture, we have studied about electric potential, potential difference and electric potential at any general point, and electric potential on the axial line of an electric dipole and on equatorial line. Now, in this lecture, we will find out electric potential at any point due to dipole. So, today's topic is electric potential at any general point due to dipole. At any point due to dipole, we will find out electric potential. So, for this, we will have to need an electric dipole. Now, let us consider an electric dipole. This, you know, electric dipole, a pair of equal and opposite charges separated by a small distance. Here, minus q charge. Here, this is plus q charge. And at the center, this is point O. And here, we will consider a general point P, not exact on equatorial line. Like this. And this is the theta. This point A, this point B, this is A, this is A. So, dear student, we will find out electric potential at point P due to this dipole. So, what will this distance is considered R1 and this distance is considered R2. Is there any problem? Perhaps no. It's very simple. And firstly, I tell you, the distance of a dipole is very small between two charges equal and opposite. So, firstly, what will we do? There are two charges, minus q and plus q. You know very well, each and every charge has its potential at finite distance, because at infinite distance every charge has zero potential, and the formula of potential is kq by r. So, dear student, here electric potential due to minus q charge, that is denoted by V1. So, at distance R1, you can say V1 is equal to 1 by 4 pi epsilon naught. You can write it also K. And Q upon, Q is minus, so minus sign is written ahead. Distance R1 equation first. And now, electric potential due to plus q charge V2, and that is equal to 1 by 4 pi epsilon naught q by R2, because distance is R2. So, net potential, so total electric potential at point P, what? That is equal to V is equal to V1 plus V2. Dear students, you know very well. Because electric potential, that is a scalar quantity. So it will be added directly. And here, what will we do? V is equal to V1 plus V2. So that is equal to 1 by 4 pi epsilon naught. Q is also taking common R1, R2, because R1 is of minus, so it is written behind. That is 1 by R2 minus 1 by R1. This is clear. And that is equal to Q upon 4 pi epsilon naught. R2, R1, R1 minus R2. Right. This is the electric potential at any general point. But dear student, but the condition is, main condition is that if point P, because this is an angle theta, simply add known role of theta. It's not possible. If point P lies far away, then अगर ये पॉइंट P बहुत ज्यादा डिस्टेंस पे लाई करे, then what will happen? And this is also equal to theta, because theta is very very small, because this is at a large distance. So for large distance we will have to draw perpendicular from here, and this distance is R1 minus R2. This one. This distance is R1 minus R2, because R1 is longer side, R2 is smaller size, and these both are equal, almost equal, because this is lies at far distance and dipole is very very small, so these angles are most theta, right? So here, now this point is C. In triangle ABC, you know, cos theta perpendicular upon, base upon hypotenuse, and that is equal to base AB, hypotenuse, this one. So this is angle base, base is AC upon hypotenuse AB. Then AC is equal to AB cos theta. AC is equal to R1 minus R2, and that is equal to AB. AB is the AA 2A. 2A cos theta. This is, and dear friend, you know very well, this is a little bit distance, but when this point lies at a far distance, also R1, R2 almost equal to R square, because they lies at a far distance point. Now, putting the value. After putting the value, what will be the result? This is R1 minus R. So V is equal to Q by 4 pi epsilon naught R1 minus R2, that is equal to 2A cos theta upon R1 R2, that is almost equal to R square. So V is equal to Q by 4 pi epsilon naught 2A cos theta upon R square. So R square cos theta plays a big role here. So V is equal to Q into 2A. You know, Q into 2A, electric dipole moment, product of magnitude of either charge into distance between them. So that is P cos theta upon 4 pi epsilon naught R square. So dear, this is the formula of electric potential at any general point due to dipole. and this formula verify each and everything. Suppose we have find out the value on equatorial line to verify to verify this formula. On equatorial line, theta is 90 degree, so V is equal to P cos 90 upon 4 pi epsilon naught r square, that is 0, as cos 90 is 0. And yes, yesterday last lecture we have discussed on axial line, V is equal to P cos 0 upon 4 pi epsilon naught r square, and that is equal to P upon 4 pi epsilon r square, because on axial line theta is 0. So we have verified both. So this is the very important topic, and dear student, again I recapitulate it. Electric potential at any general point due to dipole. First of all, let us consider a dipole, and at point P, any general point, we will find out the electric potential. Simply, this point is at r distance r1, this point has distance r2, right? And P is at a distance r. So here, electric potential due to minus q charge, that is V1 minus 1 by 4 pi epsilon minus sign refer to charge minus q. And electric potential due to plus q charge V2, that is 1 by 4 pi epsilon naught q by R2. And because electric potential is scalar quantity, so they will be added directly, and V is equal to V1 plus V2, and that is equal to simply addition. And but when this point lies at a far distance, so this draw perpendicular, and they are almost equal to, they are not 100% equal to, because the size of dipole is very small, so you can't mention 100% accuracy in this topic. Another method where we use binomial expansion, also in the binomial expansion there is not 100% accuracy. So using this concept, and we use cos theta, because they are far different, this angle is almost same, because this is the size of dipole is very small, right? So that is cos theta based upon hypotenuse, AC is AB cos theta, and R1 minus R2, that is equal to 2A cos theta, and R1 R2 almost equal to same, because they almost equal. So with this we have find out the formula. Any problem, you can contact me on my personal number. Now, another very important relation between E and V. E means electric field and V means potential. So in this topic we will find out the relation between electric field and potential difference. So for this, let us consider a charge Q. You know, each and every charge has a potential at finite distance. So here this is a point A and this point B. Positive charge, so direction of electric field is in this direction. There is a unit positive test charge Q naught, and the distance between them is dr, that is very small. Because we have studied about the potential difference at point B and at point A. There is a small distance difference in potential difference, and that is dV. dV is the potential difference between 2 points A and B. So in this topic, now let's start. Is there any problem? A and B, two potential different. At A, another potential, B, another potential of charge Q, because it depends on distance, and dV is the potential difference between 2 points. So we will have to bring unit positive test charge Q naught from B to A. Small work is done. Small work is done in bringing the unit positive test charge from B to A against the direction of electric field, and that is equal to dW minus F into dr. Because I will use minus sign, so no need to use cos 180. Also you can simply use F dot dr, and that is equal to F dr cos 180, and that is equal to minus F dr. Also you can write it if I use against word. So this is the work done. dW is equal to F dr. Also, because electric field has applied force, F is equal to Q naught E. You know very well. So you can write here that is minus Q naught E into dr. That is equal to dr. Is there any problem? So dear student, and you know dW work done, that is equal to potential into charge, right? Because yesterday, the last lecture we have studied potential is equal to work done upon per unit charge. So dW is equal to potential is dV and into Q naught. Equation first, equation second, comparing equation first and second, and that is equal to dV into Q naught is equal to minus Q naught E into dr. Cancel. So dV is equal to minus E into dr, and E is equal to minus dV by dr, and this is the relation between electric potential and electric field. dV by dr, that is equal to potential with respect to distance, so it is called potential gradient, and this is the relation between electric field and potential gradient. So dear student, very simple topic. You know, there is a charge, you can say positive charge. Electric field always move from positive charge and terminate at negative charge. So at point A and B, there are 2 points, and we will have to bring a unit positive test charge Q naught from point B to A. The potential difference between B to A is dV. So small work is done in bringing the unit positive test charge from B to A, and that work done is force into displacement, and force is applied by the electric field, and we have gone against, right? So dW is equal to F dot dr minus F dr, because cos 80 against F is equal to minus Q naught E and dW is equal to dV into Q naught. We know work done is equal to potential into charge, and comparing equation first and second, Q naught is cancelled from Q naught and dV is equal to minus E into dr, and D is equal to minus dV by dr. So this is the relation between electric field and potential gradient. So this student will have to practice it more and more. So thank you for today. Have a nice day.